Configure cabinet. Process and test is a workflow scenario that includes the configuration of a sheet metal cabinet assembly driving the resizing, renumbering, and testing of each configured component. This process ensures that each cabinet assembly meets specific design requirements and quality standards. By following this workflow, teams can efficiently customize cabinet assemblies while maintaining consistency and accuracy throughout the production cycle. This step illustrates the capabilities of the Global Edge plug-and-play configuration engine to generate complete product configurations including routings and complete engineering and manufacturing bill of materials.
Select the engineering option on the Global Edge main menu, followed by selecting the BOM product configuration option on the engineering management menu. Select the Find Part option and retrieve part number SLD-000-cabinet, which will display the following part menu options. The part that was retrieved is referred to as a master configuration part number, or could be referred to as a template part number. For this master configuration part number, configuration rules were defined for each of the configurable parts in the CAD model assembly. This also includes the definition of part numbering rules that are applied to each configured part, including each assembly part number in our demonstration illustration. We will have manual user input of the cabinet parameters such as height, width, and depth of the cabinet. The Global Edge configuration engine can automatically input parameter values from either an existing sales configurator, quoting spreadsheet, or a customer web portal. In such a scenario, the Global Edge configuration engine can run in the background without human intervention. To start execution of the configurator, select the configurator, Run option followed by the new No option to display the following screen form. Select OK, then select Yes, which will display the following screen form to begin the process of entering configuration parameters. Enter cabinet height, cabinet width, and cabinet depth within the allowable limits displayed to the right of each prompt. The next configurator prompt is to select a face pattern, which allows for the selection of various cabinet face patterns comprised of drawers, doors, and fill panels. We will bypass these selections in our illustration and select None, which is followed by entering a post height. With the next set of configurator prompts that include fill panel, removable back, include shelf, and include drawer, we will answer no to each of these prompts in our illustration. The next configurator prompt provides a selection of available materials for the cabinet to choose from. This is followed by a list of available material thicknesses for the material selected. The last configurator prompt includes selection of a paint finish for the cabinet. When the configuration execution is completed, the following menu options are displayed. The menu option BOM will display the top-level part number of the configuration that was generated. You can access a full bill of materials listing multiple levels in the BOM section of the software. Select Cancel and select the Routing option to display the routing steps that were generated for the top-level assembly. You can access routings that were generated for each of the sub-assembly components in the Routing section of the software. Select Cancel and select the Documents option to display the top-level document name that was generated to reflect the new cabinet configuration just produced. Section 6.2 of our illustration will show launching a template SolidWorks CAD model for the configured cabinet and resizing and renumbering each part to match the configuration that was just generated.
This step illustrates the automated resizing of a configured CAD assembly, including the automated renumbering of each configured CAD component.
After running a configuration for the sheet metal cabinet, return to the Part menu, select Find Configurations to access the configured cabinet. Select the Document option to display the following screen form and menu options. This will display the SolidWorks assembly file that was copied from the original SolidWorks template CAD file. Select the Launch option and highlight the SolidWorks assembly CAD file. Then select OK, which will automatically launch the original template CAD cabinet into SolidWorks. The process of configuring and resizing the sheet metal cabinet continues with the original template CAD model assembly launched into SolidWorks. Select the Tools, Global Edge, Model Explorer option to display the following screen and menu options. The upper left portion of the screen displays the current bill of material structure of the template CAD model cabinet assembly. As the cabinet assembly rebuilding process is executed, this bill of material structure will be replaced with a new configured bill of material structure. Select the Rebuild, Configure button to start the CAD model assembly rebuilding process. After the process of completing the rebuilding of the CAD model assembly is complete, the newly configured cabinet is displayed within SOLIDWORKS. Select the Tools, Global Edge, Model Explorer, option to display the following screen and menu options. The upper left portion of the screen displays the newly configured bill of material structure of the configured CAD model cabinet assembly. The lower left portion of the screen displays the newly configured bill of material structure that is stored in the Global Edge database.